viewers, for today we have a very special guest. He is Mr. Friedhelm, the Vice President of the Asia Pacific region of HIMA, a company that prides itself with years of innovation. Mr. Best will shed more light on SoC, Systems on Chip. For those who may not know, it's most probably known as a component we hear about in mobile phones, computers, and other gadgets. He will enlighten us on the importance of this chip, particularly on the industrial safety and cybersecurity side. Mr. Best, it's an honor to have you and welcome to the show.
Thank you very much for having me.
Yeah. So, sir, I guess we could kick things off by saying what is SoC for the benefit of those who don't know anything about it.
Okay, yeah. Let me start with what SoC stands for. It's System on Chip. So we are talking about electronic devices here. Some will say it's a microchip or a microprocessor. It's really on one chip. You have everything what you need for a dedicated application. This can be a central processing unit, a CPU, plus a memory, plus a graphic card on one chip. What are well-known applications or solutions of this? Apple has designed their own SoC. It's used in the consumer products as iPad or iPhone, and you heard about that they also introducing more and more their own chip in most of their products. Another product might be known to the audience. It's Raspberry Pi computer, very compact, and there's also everything for this application needed on one chip, and that's why it's called System on Chip.
Okay, so just curious, what are the key considerations when designing and maintaining designing this chip in today's infrastructures? How does it fit in? Because most of us know it tied to computers, the consumer electronics items, but no one knows its importance in the infrastructure of everything.
Yeah, so the critical infrastructure is something which we are enjoying each day. We are using here at the moment in internet connection. We are consuming power, and hopefully it is not interrupted. It's constantly there. So that's one example of a critical infrastructure. So power, communication, but also transport, rail infrastructure, even water supply, or if we go in some specific industry, gas supply. Many more examples are of critical infrastructure. So what we all would like to avoid as consumer, but especially the operators, is any interruption of this or any unplanned interruption. Now, all the critical infrastructure is a very complex systems. There are whatever in there. If we stay a little bit on railway, for instance, there's a lot of signaling, communication, mechanical parts have to work. They are activated by automation systems, so means data communication needs to be happened. All this is not allowed so that this is fall to fail. It's not that it's not communicating. If you have a single device, as we have maybe a PC or a phone, and it somehow stopped, you reboot it. In a critical infrastructure, this is what you won't like to have, because the impact of that risk is so huge, or can be very huge. So the risk is even higher there that it could be to fail. That's why you select the devices, and if it is on the electronic side, also electronic, which is more reliable, which has a higher availability, and that's what you need to implement from the design. And you could use what is on the consumer world available, but maybe it's not built for that high requirements of availability, and because it was designed to a low cost. So in the critical infrastructure, we are using industrial products mainly, and they are designed, and also a system on chip is designed due to a certain path with that. A lot of things are built in, like diagnostic, to control it itself. and, as I said, also to a high availability, and even for many, many years of operations.
Mhm. So this is a lot. This is entirely different from the chips that you have right now for the industrial side. These are different from what people know that are used on mobile phones, gaming consoles, or even computers. There's a big difference. Am I right?
Absolutely, you are right. To give you one example, our company is delivering since now 50 years
Mhm.
safety systems into industries like oil and gas, chemical industry, or railway. Once the systems are installed, these operators running the systems for 15 years, 20 years, or
Mhm.
even 25 years. If we have nowadays a PC, how many years can you run your PC and you say, okay, now it's done,
Yeah.
or your phone? So in the industries we are delivering in, uh, it's for them not acceptable. It's they are designing and building their plans, their infrastructure for really decades then, and this must be supported. It is a challenge for all us in the industry because, like a microprocessor has a lifetime of maybe a product lifetime of, let me say, 5 years or even less. Can we go there and say, oh, we need to replace it because that chip is not available? So that's why also this dedicated solutions like systems on chip are designed for this industrial applications for a long lifetime with a high reliability and availability.
Mhm. So in a way, these industrial chips are, as in terms of lifespan, they have a set number of years where they are useful. I mean, meaning it comes to a point that you have to replace them or upgrade them.
It's yes, they have also a dedicated lifetime there. It's not there. You can run them for hundreds of years. That's naturally that there are some influence. But we talk about here really of 20 years using a microprocessor in these industries. And now you can go in your own household and look for what electronic devices you have, which you bought 20 years back. Uh, and if they are still in full operation. But that's outside in the industrial area the case. And that's why it starts from the design, development of these devices, and they are very dedicated to that. And this is the job of companies like HIMA or many others outside there to have that. And this is a difference from the consumer market to the industrial market and the challenges also
Okay.
we have in that industry.
So what then are SSoC? I mean, on your end, it's called Safety System on Chip, right? So as pioneered by HIMA in your 8 Core One, what is what is it about?
Okay, the additional S on this, so SSoC, Safety System on Chip, is dedicated, designed for safety applications. So what is a safety application? Uh, there is a normal operating system which runs a normal operation. If it is, take a pipeline and the pipeline pumps are running and valves are there. So the normal operation system runs that. But there is critical things like if a pump is not running, something can happen in a pipeline or a valve is not acting. So there's a high risk, and for this high risk applications, you put a dedicated system which is designed for that, and this system has much higher requirements, and it's a little bit more, it's really more sophisticated, and the engineering and maintenance, it needs more attention. So the safety systems, the simple thing to have high availability, we say I make it redundant. If one computer fails, then the other one takes over. But that's not all. That's a little bit more complexity in that, because if you use the same computer, why is one failing and the other is exactly the same, should not fail. So that's why you build something more in. The other thing, what comes more and more is already there, all the systems are connected. If you hear about Internet of Things or Industry 4.0, what does it mean? A lot of devices are connected to each other. They are communicating to each other. Are they communicating only out? No, they're communicating to each other. And a safety system we have to be careful. We won't like that it will be, somehow, to say it, really hacked from outside, that someone manipulated, because it's a safety system. And the program, and there's always an application program there, should not change, not when it's not under control or under the design of the operator or engineer. So, but it's connected. So that leads from safety also to security. And all this is on this safety system on chip, more or less built in one chip, very dedicated to the safety application, and on a very small footprint, so that it can be embedded in many other devices, which has some electronic inside.
Okay. So how can SSoC provide better security for these and safety for these industrial plants and transportation systems?
Yeah. If you now think about, your task is to design a new controller. You go there and say, okay, I start from the scratch. I'm looking what is outside in the market, or a microprocessor or an interface device. There is whatever you needed. Say you need also a graphic card. You can buy this on the market. You grab this and make your electronic design. But all of these devices are designed maybe for something else, and you live with some compromises, and maybe there's also some backdoors in there. So you say, it's a safety system, I protect the connectivity, but you are not aware there is some backdoors in, and someone can make use of that. And this is in the industry already happened. And that's why industrial applications had been hacked, because someone found this backdoor. And this we would like to avoid. That's why we eliminate everything what's not needed. So we designed this chip specifically for the safety application, and left out everything what's for safety not needed. And we know everything what's in there. There's no thing built in, and no software, no electronic device which came from the market, and we are not fully under control. So that's why we can ensure this safety is not compromised and fulfills all safety regulations, standards, and it's very dedicated to that. So it's a very small, the smallest safety system of the world, and can be built in, and we have customers who build it in medical devices, in elevators, in pumps, etc. So now it goes into this critical infrastructure.
I see. So I guess, well, you already mentioned it. We're especially now during the COVID, we're in a time where hackers are hard at work because everybody's relying so much on technology. So what makes such an integrated safety and security so important in today's world, especially our predicament right now?
Yeah, so we see now, even during the last months, it's an increase of data and connectivity, and I think we will see over the next years even much more. So the number of active devices in the worldwide net will increase. And you can go out now and say, okay, what are devices are at the moment outside in the world? And someone with a bad target or objective will look out and say, oh, where is any backdoor I can go in? And it's one example. If in the industry a device is activated with a default password, and this is known by too many people, and no one changes default password, then it's an open gate, an open door for someone from outside. So all this is, it's one thing. The hardware used must be designed for really to protect as much as possible, but also to be connected. So we can't block all connections. That will also not work. The second step is the software, which needs also be designed, and the programming must be in that way under be full control of what's in there. And to avoid that someone from outside have not authorized access or writing access. And the last one is also the processes. If someone, let me say, the simple thing, has a workstation in a power plant and he puts the password next to the screen, then it's a process point of view. No software, no hardware will help you that another one get access to that because he got the password in his hand. So regular change of passwords, etc. So a lot of things which should be naturally, or for us already normal processes, must be in place. And it changed every month, every week, this, because all users, all designers, all engineers learning of what is the next threat. What was not known 5 years back, today everyone knows, oh, you have to do it in this way, and who knows what will be in the next part. So security is constantly work on this, and standard procedures like make updates, patches, all this is necessary. And a safety system, you take specially care of this, because you even can't shut down a safety system because you make an update. So that's coming back where we also we always say safety non-stop. So you can even make updates without shut down the system. That's for the critical infrastructure important.
Okay, so traditionally, these critical infrastructures, the safety and security implementations, were not really that designed with systems like with SSoCs. So, with HIMA's push for SSoC for industrial safety and security, will such developments see more infrastructures adopting current or future SSoCs?
Yeah, so we will see this more and more because the critical infrastructure is connecting itself more and more. All the devices of the Internet of Things have embedded or is embedded in sensors, in software, in actors, in even a small device which in the past was not intelligence by electronic gets now intelligence. One example, maybe everyone can experience this or made experience with that, and a meter in your house for measure your power consumption. In the past was, yeah, more or less a mechanical device. It was measuring the current and nowadays in many countries this gets very intelligent, and it's maybe communicating to the utility company. So another device in the Internet of Things. So and this is only one example, and it gets more and more in our environment. And all these devices are communicating more and more because the operators would like make use of this. Data are needed for diagnostic to know when the next maintenance is. So this will be dramatically increase. And as far as devices gets more intelligent, and I mentioned a few parts, if it is a valve, if it is a motor, a pump, then you need to be careful. How can you improve or need to improve the safety with the help of electronic? And then we are at the safety system on chip.
So looking ahead, Mr. Best, uh, looking at the future, what could be future enhancements to SSoCs for industrial safety and security? What do you see?
Yeah, so what we see is more and more, it's you could put it under the buzzword real-time data. So everyone won't like to wait and say, okay, once an hour or once a day I get information about the system. No, it's not satisfying anymore. You would like to get it on your dashboard as an operator or as even an engineer outside in the field would like to get real data on an app or wherever. So this will come. It's not only true that the people need to know, also the other systems behind there need to work with the data and act on this. That brings me to the thing that the machines are learning itself, machine learning. So when there is a pump, does a pump realize itself when the next maintenance is needed before something, a bearing or whatever is broken? And so we are going away in the industry of we wait until a device fails and then it will be repaired, to going for to know it in advance and then act already in a planned manner, because then you can plan when you replace a pump or bearing or whatever it is. And with that needs sensors, and the sensors gets more intelligent and communicate more and detecting more. You see it also in the cars. The cars have more information and can tell you more about this and than years back. And this is in the industry the same, especially when it comes to very expensive equipment. And when we talk about a turbo machinery, a huge pump in an industry, it costs millions. You won't like that this will be broken because you didn't identify something too late. So the sensors gets more intelligence, and then you have embedded the electronic, and then you use this also for the safety part. So all this comes together, and this analytics also of all the data, this gives a little bit the view in the future, which is today not in the installed base, the standard, but everywhere where the opportunity is to upgrade, to make new installations, this will come more and more, and this is where the safety system on chip from HIMA can play an important part, because this can be even down in a sensor, be embedded, because it's so small and have so condensed the safety aspect, which helps them to protect the machines. At the end, also the people working in this environment, even the neighborhood and the environment as well. And this is our task to ensure that all the three elements are protected.
Would you, just curious, could you share with where just the countries where your SSoCs are being used right
Yeah, so the customers are using already this safety system on chip. On one side, it's HIMA ourselves, so our safety systems are using this. The same as Apple is using their own chip. HIMA is doing the same. Maybe not everyone in the world knows it, but this is what HIMA is doing. So we had also our own use, and we are providing this to our customers, and the customers are like manufacturers of pumps,
now?
very small compact pumps with an electronic in to start to control the pump, and embedded is the safety part from HIMA. And the other is in a car manufacturing plant, there is an autonomous vehicle who transport shelves and goods from one workstation to the other. And this small device works autonomous, but is interacting in an environment where people are. So workers are walking on the shop floor there because they are assembling cars there. And so inside of this small vehicle is safety sensors. And it was so small that a safety PLC couldn't put in there. And then this customer decided to use HIMA and the safety on chip solution, because it's so small, so compact. And the whole design was in a so short time, and it was certified by the safety authorities. So that was the best solution for this customer. So we are protecting in this car plant the workers and also at the end the equipment, that it not drives in any barriers and damage anything. So that's maybe a very good example of showing where such a solution is built in.
Mm-hmm. So how about in the Philippines? Have you ever had any talks with anybody from our end here, the companies here?
When we are getting in touch with people and they ask us, okay, can I use these solutions from HIMA? What counts very high is that we are in this business already since 50 years. Mm-hmm. We were the pioneer with safety systems in the oil and gas industry, chemical industry. So we have many years of experience in that. The other part is we are only doing safety, mm-hmm. but this is our core activities and the only purpose there. and that's why we are not mixing it up with non-safety applications, and that gives a lot of credibility of that, and we have the largest number of safety systems outside in the market from all suppliers worldwide. And so our references and proof points are so impressive. And look, HIMA is a mid-sized company. It's German-based, and we are around 800 employees. But that we are capable to design our own safety chip, this counts a lot for others and say, wow, that's impressive that this company doing this. Otherwise, you hear big names in the market who design their own chip or offering this chip. So that was for us very essential for our own business and for serving our customers the best, and that shows these capabilities. And yeah, we are bringing this now here to the Southeast Asian market. And because we had already the first success in other parts of the world, and we would like to bring this here, and that's why we are here with our team to, because it's not like you go in a catalog and select it. It's also a lot of collaboration during the design phase and supporting this, and we have even large oil and gas companies who have interest in this to use it for their own production lines and to implement it there.
Well, I think that's I've gotten a lot of information already from you, Mr. Best. It's like an information overload. I'd like to thank you very much for granting me this interview, although we had to reschedule it a couple of times, and I finally able to nail it. So before I let you go, sir, I'd like to give you the floor, maybe for your final thoughts or anything you'd like to share with us.
Yeah, okay. Thank you, Brian. It was really a pleasure to give you a view into that activities we are in. And the Internet of Things will require in future more and more safety and also security we talked about. And we are looking forward to solve this with in many applications, and also to ensure the connectivities, so that helps here also in the region manufacturers and operators to run a safety system also in a critical infrastructure.
And so that's a wrap for us. Thank you again, Mr. Best, for joining us today to shed more light on the SSoC and the security things in the industrial sector in cybersecurity. Catch us again next time here on Tech News here on our Daily News Online. Thank you.
Thanks. Bye-bye.
Sir, thank you very much. Thank you so much.